Spain's largest wildfire of the year has now burned more than 32,000 hectares in Guadalajara alone, making it bigger than the infamous 2004 Rio Tinto fire that held the regional record for 2 decades. But the number that has forecasters genuinely unsettled isn't the size of the burn. It's what scientists found when they looked at what happened in the months before a single spark ever hit the ground. The fire itself has already forced roughly 1,200 people to evacuate from 34 municipalities, with more than 800 emergency personnel and around 170 air and ground resources deployed, including 100 troops from Spain's military emergency unit. It took 6 days before the fire began to stabilize, and even then, only a handful of the evacuated municipalities were cleared to return. That scale of response tells you this wasn't a minor blaze that got unlucky media attention. It was one of the largest coordinated firefighting operations Spain has mounted in years, and it happened while a third heat wave of the summer was still bearing down on the same region. To understand why this matters, it helps to put this fire next to the one everyone already remembers. The 2004 Minas de Rio Tinto fire burned roughly 29,000 hectares and stood as one of the defining wildfire disasters in Castilla-La Mancha's history for 20 years. This July's La Mierla fire in Guadalajara has already surpassed it, crossing 32,000 hectares, becoming the largest wildfire ever recorded in that region. On the surface, the comparison looks like a simple story of one bad fire beating the size of another bad fire from the past. The similarities between the two events are real and worth naming first. Both fires hit during extreme summer heat. Both spread explosively once ignited, overwhelming initial firefighting response and forcing large-scale evacuations. Both became the kind of fire that gets remembered by name for years afterward, a permanent marker in the region's disaster history. Both also occurred in landscapes that, on paper, had received reasonable rainfall in the preceding year, which is precisely why the surface-level comparison misleads more than it informs. If you stop the comparison there, you'd conclude this is simply a bigger version of a disaster Spain has already survived before. That's exactly where the comparison starts breaking down and where the science gets genuinely important. Researchers studying this year's fire season went looking for what made the landscape burn as fast and as completely as it did, and the answer wasn't just heat, it was rain. Specifically, the rain that fell 5 and 6 months before the fires even started. Here's the mechanism, laid out step by step, because it's the part almost nobody covering these fires as breaking news actually explains. This past winter brought above average precipitation across Spain, with soil moisture running well above normal levels heading into spring. That sounds like good news, and in isolation it was. Wet winters promote vigorous vegetation growth, more grass, more shrub cover, more understory across forests. But as spring progressed, rainfall dropped off while temperatures climbed steadily. All that extra vegetation the wet winter had produced didn't disappear. It dried out instead, turning what should have been a wetter, greener landscape into a landscape carrying significantly more fuel than usual, fuel that had lost most of its moisture by the time the July heat wave arrived. Add to that the fact that overnight temperatures across much of Spain stayed unusually high through this stretch, remaining above 20 degrees Celsius and exceeding 25 in cities like Madrid. That detail matters more than it sounds like it should. Vegetation and soil normally get a chance to partially recover moisture overnight when temperatures drop and evaporation slows. When nighttime temperatures stay elevated, that recovery window shrinks or disappears entirely, meaning the drying effect compounds day after day instead of resetting. Daytime highs in the same window reached 35 to 41 degrees Celsius, with local peaks of 43 layering. Extreme daytime heat on top of vegetation that was never getting a real chance to recover after dark. Scientists studying this pattern have given it a specific name, hydroclimatic rebound. A wet period doesn't reduce fire danger on its own. It sets up a delayed threat, building extra combustible biomass that only becomes dangerous once a dry, hot stretch arrives to cure it. Rainfall doesn't lower fire risk in this scenario. It quietly manufactures the fuel for a much bigger fire down the road. This is the detail that separates this year's fires from the historical comparison in a way that actually matters for prediction, not just record keeping. When investigators measured the actual fire weather conditions in early July, the numbers were extreme by any standard. The fire weather index across the Iberian Peninsula reached values between 54 and 66, with local peaks near 90 in parts of Andalusia, Extremadura, and the Balearic Islands. Readings that indicate fires capable of spreading too fast and too intensely to suppress with standard methods. Fine fuel moisture readings landed in the 96th percentile for dryness. Wind gusts hit 65 kilometers per hour in parts of the country, adding another accelerant on top of an already primed landscape. Like and subscribe if you want the science behind headline disasters like this one explained properly. Because the real story here isn't the flames. It's the 6 months of weather that quietly built them. Now here's the comparison that should actually worry you more than the size record. Fires of this magnitude, by early July, are historically associated with the back half of the Mediterranean fire season, August and September, after months of steady summer drying have left vegetation at its most vulnerable. This year's outbreak hit weeks earlier than that pattern would predict, with cumulative burned area already exceeding the historical average by the first week of July. The fire season didn't just produce a bigger fire than usual. It arrived on a compressed timeline that caught seasonal planning models off guard. That compression is the real difference between this fire and the 2004 comparison, and it's worth stating plainly. Rio Tinto happened on a timeline fire services had decades of historical data to plan around. This year's fires arrived roughly a month ahead of where the historical curve says they should have, which means every assumption about when resources need to be prepositioned, when public warnings typically need to escalate, and when the most dangerous stretch of the season begins, was effectively out of date before the season even reached its traditional midpoint. Investigators tracing the numbers found that by early July, Spain had already recorded roughly 57,000 hectares burned nationally, a total that would normally represent a fairly advanced point in a typical fire season, reached instead before the season had even entered its historically most dangerous stretch. Every additional week of summer heat from that point forward became pure surplus risk stacked on top of an already elevated baseline. Rather than the gradual seasonal buildup, fire services are used to planning around. By late July, that national total had climbed further, with 2 major wildfires alone pushing Spain's cumulative burned area for the year toward 50,000 hectares, even before accounting for smaller blazes scattered across the north and south of the country. Wildfires had, by that point, already burned more land across Europe in 2026 than the annual average recorded over the past 2 decades, according to data tracked through the continent's fire monitoring systems, and officials were explicit that this reflected 3 largely back-to-back heat waves, rather than a single unlucky spike. That timing gap is exactly why forecasters are treating this less as a single bad fire and more as a preview. Climate researchers modeling this specific hydroclimatic rebound pattern have found that under a moderate greenhouse gas emission scenario, large areas of southern Europe could see up to a 10-fold increase in the probability of catastrophic wildfire events as global warming approaches 2 degrees Celsius. That's not a vague warning about the future. It's a specific, modeled multiplier attached to the exact mechanism that just played out across Guadalajara. And it implies that events resembling this one stop being once in 20 years disasters and start becoming a recurring feature of ordinary summers. The same projections indicate that fire-prone conditions are expected to expand geographically as well, pushing into parts of Central and Northern Europe that have historically been considered low risk for this kind of large-scale wildfire activity. That expansion matters beyond Spain's borders specifically, because it suggests the hydroclimatic rebound pattern isn't a uniquely Iberian phenomenon tied to Mediterranean geography. It's a mechanism tied to the sequence of wet then dry conditions itself, one that can theoretically play out anywhere that sequence occurs, regardless of whether that region has historically needed to plan around major wildfire risk at all. It's worth being precise about what this research can and cannot claim. Hydroclimatic rebound explains why the fuel was available and unusually abundant. It does not, on its own, predict exactly where or when a specific ignition will occur, since that still depends on lightning strikes, human activity, and localized wind conditions that remain genuinely difficult to forecast with precision more than a few days out. Researchers studying this pattern are careful to frame it as an explanation for severity and fuel availability, not a crystal ball for the next fire's exact location. There's also a more speculative thread worth naming honestly. This same hydroclimatic rebound pattern, wet periods stimulating rapid vegetation growth, followed by drought that cures that growth into fuel, has now been documented in California's fire-prone ecosystems as well as Spain's, which raises the question of whether this is becoming a more universal signature of a warming climate, rather than a regional quirk specific to the Mediterranean. That broader claim is still being tested across other fire-prone regions worldwide, and researchers are explicit that it remains an active area of study rather than a settled conclusion. So what does comparing this fire to its historical predecessor actually tell you that matters practically? If you live in or near a fire-prone region, don't rely on the calendar to judge risk the way past seasons have taught you to. A wet winter is not automatically good news for reducing fire danger later. If that winter is followed by an unusually hot, dry spring, treat that combination itself as an early season fire risk signal, not just the arrival of a heat wave on its own. Check whether your regional fire service publishes a fire weather index or equivalent danger rating, and if values are already elevated well before the traditional peak of summer, adjust your own preparedness timeline accordingly rather than waiting for August the way past experience might suggest. Have a defensible space plan around your property finalized before the season's traditional peak. not during it, since this year's evidence shows the danger window can now open substantially earlier than the historical average. Clearing dry vegetation and debris from immediately around structures, and confirming that your household has an evacuation route that doesn't rely on a single road, are both steps worth completing while conditions are still calm rather than during an active alert. And if you're in an area under evacuation guidance during a wildfire, treat the instruction as time-sensitive in a way that wasn't always true of slower building fires in past decades, since the same conditions producing this year's extreme fire weather index readings are also the conditions that produce fires capable of outrunning evacuation timelines built around historical fire behavior. Spain's 2026 wildfire season didn't just produce a bigger fire than the one everyone still remembers from 2004. It produced a fire built by a completely different mechanism, one that started with rain nobody thought to worry about, months before a single flame appeared. That's the part scientists say should change how every future fire season gets read, not just this one, and forecasters are already watching to see whether this pattern shows up again next winter. If it does, the comparison this video just walked through won't be a one-time story about a record broken 20 years later. It will be the new baseline every future Spanish fire season gets measured against, and that shift, quiet, procedural, easy to miss inside a single summer's headlines, is exactly why scientists studying the smoke behind this fire are the ones sounding the most concerned right now.